In the previous video, we looked at how to declare and use optionals in Swift. In this video, we're going to take a look at structs, what structs are, how to declare it, and how they are managed in memory. Structures. Constants provided in Swift allows us to encapsulate related information. As structs encapsulate related information, we can define methods to provide some functionality, variables or constants, initializers, etc. So, let's introduce structs with a real sample of our life. We are going to assume that we have a function, like one declared in my playground. This function receives two arguments of string type that are the first name and last name of a person respectively. And then, inside the body of the function, it prints the first name followed by the last name. So, if we call the function with my name, it should return my full name. It's working. This is good. But what if the number of persons, first name and last name, grow, and we need to keep an array to store the first name of each person and another to keep the last name of each person? This is awkward, and the structs come to our rescue. Instead of having two separate arrays for each one, we can define a struct type person that stores two main variables, its first name and last name, and simply pass the instance of person as an argument in the function. The syntax to define structs begins with the struct keyword, followed by name and a pair of curly braces. Everything between the curly braces belongs to the struct. So let's define our person struct with the syntax explained, and let's declare two variables inside the body of the struct of string type to store the first name and last name of the person. Now, we have defined our struct. It's time to instantiate one person. To create a new person value, we use the name of the type along with parentheses containing both the first name and last name parameters. Swift defines this initializer automatically. We will cover more about initializers in structs layer. So, let's create a constant called person1 to store my first name and last name. Now we have person type defined in the constant person1. How can we have an access to the variable declared in the body of the struct? Nice question. The way of accessing to the members of the struct is using the dot notation. Let's see it in action. Print the first name property in the person1 constant, and it shows my name, Victor. Great. We can modify the members of the struct as well as use the dot notation. Let's change the first name of the person1 constant. But wait a minute. Person1 was defined as a constant, hence we cannot modify its values. Yes, that's true. We need to change the person1 constant to a variable instead. So let's change the first name to John. And it's done. We have changed the first name of person1 using dot notation. Excellent. But wait, we also need to change the method print full name of person to take it as an argument, a person struct, and just print its name. Let's do it. We call the new parameter person of type person, and inside we accessed its members as explained before. Let's move the declaration of the person struct and the variable person1 up to make visible the function print full name of person, and then we pass an argument to the function person1 variable. Swift defines a special function called Initializer to define the initial values of the members in a struct type. It automatically creates a default initializer for us. such as the one shown above. That takes each member as a named parameter. We can create our initializer using the init keyword. So let's define a new initializer with one argument, the first name of the person. One interesting point is that if a method parameter and property have the same name, you can use the self keyword to give the compiler explicit context if you want to operate on the property. When you use self in code, you're explicitly accessing the current value of the named type. In the initializer, we will define the parameter name as same of the property first name. And inside the body, we are going to use the self keyword to refer property and not the argument passed to the initializer. As soon as we define a custom initializer, Swift won't add the automatically generated one. If we need it, we'll have to define it. OK, we change the call to initializer when we create person1 and remove the second argument. But wait, we have a compile error just after the initializer tells us that we have not set the initial values for all the members in our struct. This is because by the end of the initializer, the struct must have initial values set in all its stored properties. So we need to assign a value inside the initializer to the member last name. Let's put in Doe. Great. Problem solved. One of the advantages of struct type is that we define functions or methods inside the body. So we can define the function print full name of person, and we need to change it a little. Let's start by copying it and put it in just after the initializer is declared. As we can see, there is no need to pass any more person parameter to the function because we are referring to instance itself, and inside the body we can use the self keyword to access the member of an instance, in this case the last name and first name of the person, can be finally changed to print full name because it's inside the person struct. And then we can fix the call we made before. Just to call it using the person1 instance using the dot notation. Another important point about the structs is how they are managed in memory by the compiler. Let's see an example. Define a new instance of person struct called person2, and we set its initial value equal to person1. Then we set the first name property in the person2 instance to Victor. If we put one line person1 dot first name and in another person2 dot first name, we will see that the values are different even when they are supposedly equal. This is because in Swift the structs are value types. A value type is one whose value is copied when it's assigned to a variable or constant, or when it is passed to a function. So they're separate variables with separate values. Finally, one interesting point is in Swift, all the basic types like integers, floating point numbers, booleans, strings, arrays, and dictionaries are value types and are implemented as structures behind the scenes. In this video, we learnt how to declare and use the struct data type to improve your code's clarity, flexibility, and reliability, and how they are managed in memory by the compiler. In the next video, we will learn about the fundamental data structures used in Swift, arrays and dictionaries. See you in the next one.